Continuous integration, CI, is one of the most important and fundamental best practices in software development, especially when doing modern agile software development. And it doesn't have to be a big effort, a massive thing. Just using continuous integration with, for example, a Java Spring application can be incredibly simple to do with any and every project. Today, we're going to walk through it with a small Java Spring application, and we're going to hook it up to a full CI process running in GitHub using GitHub Actions. So let's jump into it. This session won't be a full overview of what continuous integration is. There are many great books, articles, and videos on that. For today's session, I want to dive into the key pieces here to do continuous integration for our Spring Boot application. So in a nutshell, continuous integration is continuously, so every time you're making a change, running your integration, your tests on your code base on that change. So you are very rapidly getting feedback on whether that change was successful or not, whether that change broke the build and your tests, or if they continue to be successful. And you want this quick feedback and the ability to know that things are working quickly so that you're able to, again, quickly respond. So while the change is fresh in your mind, fresh on your laptop, you're able to go in, make any fixes that are needed, and get back to a stable state. And especially if you're working on a team of developers, that way you're not breaking the rest of the team or blocking the rest of the team from doing their changes. So this is a very key part of agile development. And it all starts on your developer laptop. So as you're developing your code, your Spring Boot application, a key piece here is that you're writing tests. So you're writing unit tests, JUnit tests, for example. You're going to generally want to run a local build on your laptop before you commit it or check in to make sure you're not breaking things. And then you're putting in your commit, your git push, your pull request into your source control management system. In this case, we're using GitHub specifically. That will store our code. And then every time there is a push or a pull request, this will trigger our continuous integration. In this case, we're using GitHub's Actions. This runs our CI. And in this case, we're going to run a really simple but typical CI process. So we are going to compile our Java code. We will package that up into the Spring Boot Uber jar, the self-executable jar that has all of our dependencies. We'll compile and run our JUnit unit tests here to make sure that we're not breaking the build, that our code is still passing our unit tests. We have the option to run what I'm calling checks here. This could also be called linting. Things like code coverage, find bugs, code quality tests, any other type of quality check type codes. And then we're going to save this to our Artifactory repository. So we will publish this to an Artifact repo. In this example, we will just upload it to GitHub so that it's available. But in most cases, you would be publishing this to something like Artifactory or another Artifact repository. So this is the flow that we're going to go through today, which is a pretty standard CI, but it's really powerful in what it can do. And by making this super easy, you can focus on your code and your unit tests, which is really the value and the hard work here to make sure you have good code quality. Let's go ahead and move over to Visual Studio Code. So we're again looking at our Acme application, a straightforward Spring Boot application. I've added a simple REST mapping here to say hello. So if we go ahead and run this, and we got an error here. Occasionally, I just have to clean the workspace cache to make VS Code happy. It seems to get in a conflict with the Gradle build. So if you ever see that, follow its suggestion, reload your workspace. I found that it pretty much always works. We can see Java's happy down here again, and hopefully we should soon see it firing up our application. I'll leave that in the video as I've been seeing that quite often with VS Code, and that's just good to know. So let's go ahead and try that again. All right, here we go. We see Spring Boot coming up. You see the Spring splash screen. It is up and started. And if we go to our browser, let's go ahead and launch a new tab, and we will go to default port, localhost 8080, hello Spring Boot, and GitHub Actions. Great. We have our working application. So let's go ahead and start adding that into GitHub. That way we can trigger this. I've done none of this yet, so it doesn't have a Git repository. It's not checked in. So let's start from scratch there. In GitHub, we will go to repositories. We will say, let's create a new repository. I am going to call this Acme for our application. This is our Acme Incorporated app. We will keep it public, and I'm not going to add any files because I already have my existing files. I don't want to have files in the new repo to start. So I'm going to ignore all the ignores, or ignore all the files, including the git ignore, create the repository. And then the instructions right here are exactly what I need. So we'll start with creating a README, good best practice for our file. So in Acme, where I've got all of my code, I'm going to start there. So this will be Acme Inc. app, just a really simple README to start us. And then we'll follow the rest of the commands here. First one, git init. So this will create the Git repository on my local machine. I'm going to git add, and in this case, I'm going to add all of my files. So minus capital A. So if we see git status, we will see a bunch of files, my source, my Gradle file, etc. And then we will do git commit minus M. This will be our initial commit and our comment. And then I'm going to steal these other commands because I can never remember them exactly, but we're going to set the branch to main. We are going to add my remote, which is what makes these instructions super nice, is it gives you the exact URL. And then we are going to push that to our origin. So that is, the origin is GitHub and then the main branch. So that has been pushed. If we go ahead and refresh this page, we will now see all of our code. We'll have source main Java. We have our build.gradle. Yeah, I didn't show this earlier, but this is the same one as in the prior video. So we're using Spring Boot, latest version, Java 21, I believe is, yeah, Java 21 is in here, Spring Web and a couple other dependencies. So we have our application here. It is in GitHub. So that is the first step. We have committed it. Now we want to set up the action and the trigger. GitHub makes this really easy with a template. So if we come over here in our repo to actions, we have none so far. It's going to suggest some. And this is the one we want, Java with Gradle. You may have to search for Gradle if it doesn't show up by default. We will hit configure. And we have a sample file. For the sake of this video, I'm going to edit it right here. We will clean up a couple of pieces. So this is Java CI with Gradle. We're going to trigger this on either a push or a PR on the main branch. And some of this is more boilerplate. It's going to run on an Ubuntu VM. I actually want to use Java 21. So we are going to do Java 21 here. And we're going to set up Gradle. That is great. And this is the big this is the money command. So this right here, this does all of the heavy lifting. So this .gradle w build is going to be the piece that compiles my code, builds the jar, compiles the tests, runs the tests, packages everything up. So this does 90% of the work, which is what makes this so easy. And then this template gives us another one for dependency submission. Again, I want to change this to Java 21. And what this one is going to do is scan my code for my dependencies and build a dependency graph that is integrated in with GitHub. So this will be a great way to see what are all my dependencies, what's out of date, that sort of thing. So this looks good. This is a great starting place. Let's go ahead and commit that. And we'll commit directly to main for the sake of this video. So we have that committed. If we go to our main page, we can look at a couple of things. We see that we have committed that. And we're going to now see this little yellow icon, which shows that the GitHub action is in progress. So I'm going to close that and actually go directly to the action. We can see we have our one GitHub action. You can have many here. This is running based on that check-in. We can click into the build and see exactly what it's doing. It's a super nice UI. This reminds me a lot of Concourse back from Pivotal. Everything is defined in YAML. Everything is run on ephemeral runners. And you have the nice UI to visualize and see the output. So here we can see, again, this is the main command, compile, building the boot jar, compiling the tests, running the tests. That is all successful, and it is doing some cleanup. So our build has succeeded here. Our dependency submission has failed, which is actually expected. There's one other piece of configuration here that you have to do to get this to succeed, and that's to turn on the dependency graph. So you can come over to Insights and Dependency Graph, and I just have to click Enable here. Now that's enabled, we can just go ahead and rerun that action. So we'll come back here to the failed, and we will say rerun failed jobs. We can watch dependency submission. This should be pretty quick. Okay, it's just doing its cleanup. We don't need to watch that. We can go back to Insights, go to the dependency graph, and we'll see that it has built the list of all of our dependencies. I believe everything's up to date because we're on a modern version. So you can take a deeper look at this once you've enabled it. So if we go back here to our code, we can see that we have a green check mark. It has run our CI process. So let's add one more piece to this so that we upload the jar that it has built. So if we go back to VS Code, we can stop it from running. We need to remember to do a pull request, or not, sorry, we need to pull down the latest. So we have the latest code here. So we did basically behind the scenes a git pull there to get the latest. We can now see under our Explorer, we now have a .github folder with workflows. And in there we have our Gradle.yaml. So this is our action. This is our workflow file. So same one we saw before. What we want to do here now is add a command to go ahead and upload the jar file. So I'm going to grab this from a text editor and go ahead and paste this in. And we'll just clean up the formatting. So this is calling an upload artifact command to upload the jar. and we will upload that jar that we are building. So in this case, it's really simple. We're going to upload it to make it available. As I mentioned before, you're probably going to want to put this to your Artifactory or your GitHub artifact repository. But we've made this change. So let's go ahead and check it in, and we will say upload jar for the comment, and we will push that up to GitHub. I will mention that there is a plugin for GitHub Actions in here. So I get the code validation and completion in my action files. You also have a little status window here. It's not the greatest. Basically, it will just show you the runs and you've got to hit refresh frequently, but it is nice. It gives you a direct link to go to GitHub to see how that is going. If we go back to GitHub and do a refresh, we can see again, it has a pending build. We can go here to watch it, and it'll do the same thing. The nice thing here is it's running it on an ephemeral runner. So you're getting a clean Ubuntu VM every time. So you don't have to worry about having the wrong versions or something conflicting due to a prior run. That makes it very repeatable. We see build with Gradle wrapper has succeeded. We have our new job, which is to upload the jar, which has succeeded. I've recently been seeing these errors in terms of caching some of the pieces. May look into that a little bit later. It could be a transient error that we're just seeing in GitHub. But now that that is successful, we can look at the summary of this job. And this is where we see all of the output from the job. And again, we see these errors with the caching. Those are safe to ignore for now. But we see in the artifacts, we have the jar. So this is our Spring Boot Uber jar, the executable jar. We can download it from here. We get the SHA digest right here so we can check it out. So one other Easter egg that we're going to do is we are going to add the status icon to our README. So if we go back to our action, we can click on the ellipsis and say create status badge. And this will give us the code or the markdown for that status badge. So if we copy that, and let's go to VS Code and open our README. And this is just the simple README we had before. You know, this is my app, but we can now add this badge. And if we go ahead and save this, and we will check it in, status badge, we will sync the changes. And when we go back to GitHub and go close out this and go to the main page, we now see the status badge. So we have Java CI with Gradle and it's passing. And you can add multiple badges here. So if you have CI and then CD and security scanning, you can have a badge for each of them. And then your users can quickly see, you know, are the builds passing here? So this is a very cool thing that all the common, you know, the cool kids are doing on their GitHub projects, especially when working with GitHub Actions. So that is all for this application. One other thing that I will show you is a more advanced example of this. So I have another project here, Pivotal Spring. And if we look at the actions here, I have a couple of different actions. I have the same CI with Gradle. I also have a CD job to deploy this application to a runtime. That will be a future video. I also have Sneak Security enabled to do security scanning. Can also be a future video. And then I have a sample GitHub action. This is where I was learning GitHub Actions, different triggers, different steps. You can do a lot of different things, including, you know, jobs in sequence, jobs in parallel, etc. But for this one, if we look into my CI job, I'm going to go ahead and click into it just so I can look, easy way to get to the workflow file. So very similar. CI triggered off of a push or a PR, running on Ubuntu, Java 21, latest Gradle. In this case, I'm going to set up some variables. I'm doing semantic versioning. So this grabs my version number based off of the GitHub run number, creates the version. It's going to extract the proper name for my artifact, and I'm going to build the Docker file name, so my OCI image. Again, the key command here is running Gradle W build. That's all you got to do. This will compile, assemble it. In this case, I am doing some linting, some checks. So I am running, and you'll see this down below here with the uploads. I'm running spot bugs. I'm running Jacoco, so this is the code coverage, and then I'm running check style. And here I'm uploading each of those 3 reports so you can see them. Here I am publishing my jar file to GitHub packages. So this is paired with the Gradle command publish, and then I give it the build number to build the right name or to publish that right name. And this will take in, you've got to give it your GitHub username and a secret here for it to have permission to publish to GitHub packages. And I'll show you this in my Gradle file here in just a second. And then we'll build the OCI image. So again, with Spring and Gradle, this is super easy. You run Gradle, and then the command, I have a sub project here, but the command is build boot image. And that builds an OCI image. I then log into Docker Hub, tag and push the image, and that's on Docker Hub. And then here, nice thing you can do is you can print out information to the summary. So if you go to the summary tab here, you'll see for this prior build, I printed out, here's the build version, here's what I created, here's the full version, et cetera, et cetera. You can see down here, I've uploaded a bunch more things like my code coverage report, et cetera. And I know code coverage is controversial, good and bad. Won't get into that, but I'm running it here. And like I said, the other thing I will show is in my build.gradle, you can see I've pulled in check style, Jacoco code coverage, spot bugs, and then, so this is a multi-project Gradle file. So you'll see some of the sub-project pieces here, but you'll see there is a section for publishing. And yeah, there shouldn't be anything secret here, but this is the Gradle configuration that works with this to say, hey, we're going to publish this to GitHub packages, and here's the username and token. And then what you'll see is once you run the build, if you go to GitHub and look at your packages, I then have these packages where I'm uploading. This is a client server application. That's the multi-part. So you'll see the client and the server and a whole bunch of different versions. So we'll go ahead and stop the video there. Thank you for watching and have a good day. I'm adding this one section here. If you recall before, in my summary, I was seeing a bunch of dependency submission errors. So this is caching that GitHub Actions does. So it doesn't have to re-download your dependencies every single time you run. I was seeing those errors both in the summary as well as in the logs here. I think it was in the post setup, be showing it as clearly in the logs. But when they were scrolling by, I was seeing those as well. I actually found out what the fix was. We can go back into my code and look at my last commit because this fixed it. And the fix here was in the Gradle.yaml that is suggested to us by GitHub Actions. For setting up Gradle, it says use this particular exact version. I'm assuming that's the hash. I changed that to just say, hey, use whatever the latest v4 is, before tends to be the latest. It seems the same for Java. So I changed it both in the main build job as well as in the dependency submission, and then went ahead and ran the action, or I checked that in, which triggered the action, and no more errors down here.